In today's lesson, we are still going to be focusing on right angle trigonometry with right angle triangles. However, today we're going to be looking at finding angles. So again, a little bit of review from yesterday and from hopefully grade 10, right? We want to label a right angle triangle appropriately with the correct size before we, we start using any of our right angle trig ratios. Right? We need to make sure we've identified that it's a right angle triangle. We need to label the hypotenuse, the opposite, and the adjacent. And this should be the first step that we use or that we do when we're dealing with right angle trig, because labeling it correctly will help us determine what sides we're dealing with, which will then help us determine what ratio we're using. If we use the incorrect ratio, then that could give us the wrong answer. So from yesterday, again, we should have a right angle triangle. So we should see our little square in the corner. So this, again, a lot of this will probably just be a review. This will be our 90-degree angle. Across from our 90-degree angle is going to be our hypotenuse. Right? Our hypotenuse should be the longest side. With the hypotenuse, our other two sides, the opposite and the adjacent, this is going to be dependent on the angle we're given. Right, so I'm going to put this one in a different location. Let's say we're given this angle up here. So this is, again, this is theta, just a Greek letter, and this references an angle. And in this case, this angle is going to be our reference. So theta represents an angle. It's going to be our reference. So now in this example here, we don't know what the angle is. In the question, in the scenario, we might know what this angle is. So we'd have a measurement here. But for our purposes, I'm just leaving it as theta as an unknown angle right now. Now with that reference angle, across from that reference angle is going to be the opposite. Or you could think opposite is across from, its opposite. You're on the opposite side. So the side opposite of our angle is the opposite. That only leaves one other side. I think I don't know what the spelling was there. Adjacent. So this side is beside the angle that we're given. Or you could use process of elimination. If you have the opposite and the hypotenuse labeled, the only other side is the adjacent. So that is beside our reference angle. Now, we talked about three different ratios for trig. Right? We had the acronym. I'll just write it off to the side. We had SOHCAHTOA. So SOHCAHTOA. That's the acronym that represent our formulas. But again, SOHCAHTOA, sine is O over H, or sine of an angle, or sine theta is opposite over hypotenuse. Cosine is adjacent, or A over H, so adjacent over hypotenuse. And tan is TOA, or opposite over adjacent. So those are our three ratios for right angle trig: sine, cos, and tan. Now, when we're finding angles, so because this lesson is focusing on finding angles, whereas the lesson from yesterday focused on finding side lengths, when we're finding angles, we want to use what is called the inverse. And what the inverse is, hopefully you remember, or once you see it, hopefully it kind of rings a bell. The inverse is when we have what looks like an exponent of -1 on our ratio. Now this is a button on your calculator to get that -1, right? So whenever you see your tan, cos, or sine, cos, or tan buttons on your calculator, you should see a cos or sine, cos, or tan -1 just above it. Right? If you're using a phone, you probably have to hit second function first, or some version of that, to be able to then switch over the buttons to see these inverse ratios, or the inverse button. So the inverse, we see this little theta sign. So theta, again, is this symbol. So that's representing an angle. So these have already been rearranged. So really all we're doing is just the inverse of our ratio, and we're just plugging in our sides. Right, so the sine -1 of opposite over hypotenuse, cosine -1 adjacent over hypotenuse, tan -1 opposite over adjacent. So you can just use these formulas and plug in your information and just one calculation. Some of the other ones, we are going to look at some examples just so we get a little bit more comfortable using our calculators, doing these calculations, seeing algebraically what it looks like. So for the first one, we're going to be looking at sine. Right now, before we even get into solving for a missing angle, just want to make sure we're comfortable using our calculators, finding that sine -1 button and using it to figure out an angle. So if I do the sine inverse of 0.4321, I get an answer of 25.6 degrees. So that means that this angle would be 25.6. We can do the same thing with the next one. Again, we're just using our calculators, the inverse of sine. So make sure you find that shift or second function button, or that second button, to determine to get sine -1 on your calculator. And here we're going to do then 17 divided by 14. If your calculator is strong enough, and most scientific calculators are, you should be able to just do sine -1 and then in brackets 7 divided by 14. If you're not using a scientific calculator, you may have to determine what 7 divided by 14 is first and then plug it into the inverse. But hopefully you get that your missing angle in this case would be 30 degrees. So make sure you're able to calculate those two numbers. Because if you're getting something wrong, then there's something either wrong with your calculator or you're plugging it incorrectly, which would then affect your final answers or your calculations when you're plugging something into the actual equation. So in our example with our triangle, we're actually going to go through and try to find our missing angle. Again, first things first, we want to label our sides. So I have my right angle. Across from the right angle is the hypotenuse. I have my reference angle, which in this case is unknown. This is still going to be our reference. Even though we don't know what it is, it's still going to be our reference. So here it's labeled as x instead of theta, which is fine. It's still an angle that we're going to use as a reference. Across from that angle is 7, so that is the opposite. And then the last remaining side is the adjacent. The two sides we're dealing with, in this case, it's the two sides that we have information for. O and H, we're given those two sides, so I can plug them into my formula. So theta equals sine -1 of 7 over 14. And oh, this is the exact same thing that we just calculated. So, oops, let me actually move this down. Probably proper form would say that we should write out our formula first without anything substituted in. And then we substitute our formula or numbers in. And this just becomes one calculation, right? Sine -1 is just a button. We can then do 7 divided by 14, which we've already calculated in the first example, and we should have then 30 degrees as our missing angle. So really when we're finding an angle, it tends to be one of the easier calculations. You're just plugging something in, and you're just plugging two numbers in and calculating. So this is more, are you able to use your calculator properly? Next one is cosine. When we're dealing with the cosine ratio for finding an angle, again, similarly, we want to just make sure we can use our calculators properly. So doing cosine -1 of 0.5, we should get an unknown angle of 60 degrees. And then doing it again for cosine -1 of 5 divided by 19, or 5 over 19, we should get an unknown angle of 74.7 degrees. Now, you can round that to 75, right? You can round even the side lengths that we did in the last lesson. You can round that to the nearest whole value. Just make sure you're rounding it correctly. With an example with an actual triangle, we are going to plug in our, we're going to label our sides first, sorry. So opposite of our, or across from our right angle, we have our hypotenuse. We have our unknown angle that we're going to use as a reference. So across from that is the opposite. And that means beside it is the adjacent. We are dealing with A and H. So that means we are dealing with cosine. So theta equals cosine -1 of A over H. Plug in the information that we know or that we're given. The adjacent is 15. The hypotenuse is 23. And now this is just a calculation very similarly to what we just did. And we get an angle of 49.2 degrees. So that is the measurement. Let me just make it look a little nicer. 49.2 degrees is the measure of our unknown angle. And as you see, it's the same kind of process for solving that, for that missing angle as the sine. So you can probably imagine what tan is going to look like, just with different values. So we want to go through, again, just practice using our calculators. So inverse of tan of 1.56, we get 57.3 degrees. And the inverse of tan of 6 divided by 19, you get 17.5 degrees. Now, if you ever happen to get an error when you're trying to use tan or any of these ratios for finding an angle or a side, then chances are either you've punched in a number incorrectly, there's kind of, you're missing a bracket somewhere in your formula, so your calculator is not recognizing the correct order of operations, or you've put the side lengths in the wrong spot, right? So sometimes if it's in the wrong spot, you can't get an angle because it's basically saying that the way you've entered the information, there isn't a triangle that exists with that setup. So just make sure you kind of go, if you get an error, you go back and you double check that you've entered everything correctly. So with an actual triangle, again, we're going to label our sides. H is across from the right angle. O is across from our reference angle. A is the last remaining side. We are dealing with O and A. Those are the two sides that we have information for, which is tan. So theta equals tan -1 of opposite over adjacent. And again, this is for finding an angle. So tan -1 of 13 over 9. That just becomes a calculation. So the inverse of tan of 13 divided by 9, we get 55.3 degrees. So that is the measure of our unknown angle. So finding an angle tends to be relatively easy, or not easy, sorry, relatively simple, because you're just plugging information in and then just calculating, especially because we're already using a rearranged formula. If we were kind of going back and using our trig ratios like we see here, then that might be a little bit different because we have to rearrange it then. But because we're already given the rearranged formulas, it does make it a little bit easier to just go through and find our unknown angles. So now again, that should be again review from grade 10, but now we have reviewed how to find missing side lengths and missing angles using right angle trig.